Hey guys, Kenna here. So today we're going to be taking a look at wind power, and this is one of the fastest growing segments of the renewable energies market because it has a much faster ramp up time than what you see with the other types of energy. So let's go ahead and get started and take a look at our essential questions for today. Number one, how does wind energy work? I mean, what causes the wind, and how are we going to go ahead and extract energy from that? Number two, what are the two major types of wind turbines? How are they different? Number three, what are the advantages and disadvantages of wind energy? Number four, what are high altitude wind power options? So there's something that we're kind of looking at that's a new technology coming out that's called high altitude wind power. And how is that different from what we've seen in the standard turbines? Okay. So first of all, what makes wind? Wind is a form of solar energy, just like a lot of the others that we've looked at in terms of hydroelectric when we were looking at sun is driving it. Okay. Wind is caused by the uneven heating of the Earth's surface and the rotation of the Earth. Wind turbines convert the kinetic energy of the wind into mechanical power, which then runs a generator that converts the mechanical into electrical so that we can use it in our line. But what you see these land breezes and sea breezes because of the uneven heating and the development of these convection currents, which not only happen on the small scale, but we also see this in terms of the gyres on our planet as well. So let's take a little look at global wind patterns. Okay, you see standard winds that kind of go. You're probably the most familiar with, like the jet stream, for example, or the trade winds, which are around the equator. These are noticeable winds that are predictable patterns, and that's one of the benefits of wind is while it may not always be there, there's a tendency for it to go ahead and go in certain directions predictably. Okay. Now, wind power is not new either. The first usage of a large windmill to generate electricity was actually built in Cleveland, Ohio in 1888 by Charles F. Brush. The brush machine was a post mill with a multiple bladed picket fence rotor, 17 meters in diameter, featuring a large tail hinged to turn the rotor out of the wind. It was the first windmill to incorporate a step up gearbox with a ratio of 50 to 1 in order to turn a direct current generator at its required operational speed. And for this particular example, that's 500 RPMs. Okay. So wind power is the world's second fastest growing source of electricity after solar cells. So solar energy and wind power are the fastest growing parts of the market in terms of renewable energy. Hydroelectric is pretty tapped. And some of the others, when we start looking at geothermal, it's hard to find sites. And so that's fairly stable as well. When we include the environmental cost of using energy resources in their market prices, wind power easily becomes the least expensive and least polluting way to produce energy, which is why it's one of the more popular options in the renewable market. And it's much faster to ramp up, as I mentioned before, than what we would typically see in like a hydroelectric plant or something along those lines. All right. So what we're doing is we've discovered in terms of scale that tall, long blade turbines can extract more energy from the wind than our little small turbines. Now, some people don't like them. They think they're kind of an eyesore, but they're very effective at producing electricity and is rapidly growing as a power source in countries in the United States, Europe, and China. And I think what you're going to see in the next coming 25, 50 years is a move towards offshore wind farms because wind power really has the potential to produce about 40 times the electricity currently used worldwide. Biggest trouble, like when we were looking at solar, how do we store it? How do we transport it to get it where it needs to go? The table on the next page is going to show you the US electricity generation from renewables and take a look at wind. Okay. While hydropower and geothermal are pretty stable, biomass as well, you can see that wind power in particular has taken off and solar is on the rise. Hydro has ticked up a little bit. We're doing some more of these small scale projects, but your major hydropower plants are probably pretty stable here too. So what parts of the US, what states are we looking at that are really tapping into the wind? Well, Texas is far and away the biggest U.S. investor in wind power. Uh, Us here in Oregon come in at number 11. And wind technology is on the rise, and you're going to see more states invest more in this. The biggest problem we seem to be having right now is the ability to integrate the energy produced from these wind farms into the current electrical grid setup. Okay. So here is the annual installed US wind power capacity. And you can see just from this graph, it's a steady climb. And I think you're just going to continue to see that to occur. The potential exists across the United States, maybe a little less when we look at some of the New England states. Again, part of that is size and how much of it has already got cities on it. But there's a lot of wind potential, and there's a lot of wind potential that hasn't quite yet been tapped. We start looking at places like Nevada, for example, or you start looking at places like Montana. Um, Here historically they were not really tapping into these. You can see the 1999 numbers. Total megawatts produced about 2,500, but by the time you get to 2018 you see more and more of these states tapping into it, but the numbers in places like Nevada and Montana that have high potential are still pretty low. Okay. But you're seeing more and more states delve into wind power. And the biggest problem, as I mentioned before, is probably access to the transmission grid. It's not cost, because in 2017, energy produced by wind power was less than 5 cents a kilowatt hour. A big part of it is the ability to tap into the grid, and it's harder to access and transport the captured electricity into the grid. And some of that is just the infrastructure that exists there. When you start looking at the grid, there's all that space, especially in places like Montana and Nevada, but you still have to go ahead and get the lines in place to go ahead and tap into that grid and make sure that you know where that electricity is going to go. Worldwide, China is far and away the biggest investor in wind capacity. You can see the US is next behind that, Germany, India, Spain, the UK. The rest of the world actually does less wind power outside of this list than the US and China does. And so while China, I think, gets a little bit of a bad rap for its ramp up in terms of coal, it actually is developing really good infrastructure for renewables that it may be able to offset over the years between hydropower and wind in particular. All right, so what do these turbines look like? Well, it turns out that there are two classes of turbines based on the orientation of the rotor. You have your vertical axis turbine, which is up and down, and your horizontal axis turbine, which is horizontal. Um, so when you start looking at this, this is the positioning of the axis that is going to go ahead and spin. And there are benefits and drawbacks to both. I'm going to focus here primarily on horizontal because that seems to be where most of the investment is, but we'll really quickly take a look at the advantages and disadvantages of your vertical axis turbines. So the vertical axis turbines are omnidirectional, which means they can get wind from any direction. There's no front or back to the turbine. The components can be mounted at ground level, which makes them really easy to service. And they're lighter weight towers, so you're actually seeing some of these go up on top of buildings in certain cases. Theoretically, they use less materials to capture the same amount of wind. Size still impacts how effective they are at capturing wind, but there's potential here in this particular field. So what are the disadvantages? Most cases, the rotors are near the ground and you have a lot less wind. Okay? The blades get a lot more stress from the centrifugal force, which, the forces pulling out because of the rotation. And so when we start looking at this, maintenance costs may be a little higher. They don't self-start well. So if they stop blowing, they may need a little Kickstarter push to go ahead and get them going before they really start humming, which requires a more support at both the top and the bottom. And the entire rotor needs to be removed if you do need to replace the bearings, which has had historically poor performance overall and poor reliability. But if we can solve some of these technical challenges, I think this could still be a very beneficial technology. With the horizontal wind turbines, there are various different scales. We have small ones which can do homes, farms, a couple of remote applications, but we also have intermediate, which are a little larger, and then the large scale wind farm turbines, which are pretty big. Now, if you're not familiar with wind turbines, there are four major components: the blades, the hub, the nacelle, and the tower. So I have a little video here that's going to go ahead and go over how this works.
Every 24 hours, wind generates enough kinetic energy to produce roughly 35 times more electricity than humanity uses each day. And unlike coal or oil, this resource is totally renewed each day. So how can we harness this incredible amount of energy? And is it possible to create a world powered entirely by wind? The basic principle of wind energy is simple. A series of sails or blades mounted around a rotor catch the wind and translate its kinetic energy into rotational energy. Traditional windmills use that rotational energy to grind wheat or pump water. But in modern wind turbines, it turns a generator that creates electricity. This conversion from wind to rotational energy to electricity has defined wind turbines since their invention in the late 19th century. And there are three primary factors that determine just how much energy they can produce: the size and orientation of the blades aerodynamic design, and the amount of wind turning the rotor. First up, blade orientation. Wind turbines can be designed with their rotor on a vertical axis or a horizontal axis. Vertical blades can pick up wind coming from any direction, but with much less efficiency than horizontal axis rotors. Horizontal designs allow blades to capture the wind's full force by tracking the wind's direction and turning to face it. This turning process is called yawing, and older windmills achieved it through manual monitoring. Today, wind sensors and computer systems automatically adjust the blades with expert precision to capture as much energy as possible. Outside rotor orientation, the blades themselves need to be shaped to maximize efficiency. While early designs used flat blades, modern blades are curved like airplane wings. Wind travels faster over the curved surface, creating a low-pressure pocket above the blade that forces it upwards. Since the amount of lift depends on the angle at which the wind is moving relative to the blade, modern blades also incorporate a twist, optimizing how much of the blade can cut into the wind. Made of fiberglass and resin layers, these blades are strong enough to operate through rain, lightning, and blistering sunlight for over 20 years. Even with aerodynamic blades and a horizontal rotor, a wind turbine can only capture wind if it's in a windy environment. Wind speeds typically increase the higher into the atmosphere you travel. So today, most turbines are well over 100 meters tall, with equally large rotor diameters. A turbine of this height and size can capture a huge amount of wind, generating enough electricity every year to power 750 American homes. A wind farm of 200 similarly sized turbines could power over 150,000 American homes, or twice as many European homes, for an entire year. Offshore wind farms contain an even greater number of even larger turbines. In 2019, the largest wind turbine ever built began operating off the coast of the Netherlands. With a rotor diameter of 220 meters, just one of these turbines can meet the annual power needs of 16,000 European households. Despite its amazing potential, wind energy still faces challenges. Wind may be a free and unlimited fuel, but no matter how large or efficient a turbine is, there's a mathematical limit to how much wind it can convert into electricity. German physicist Albert Betz calculated that since some wind must remain to keep the blades spinning, a turbine can only ever capture 59.3% of the wind's energy. Additionally, some people feel turbines disrupt natural scenery, and wind energy's intermittent availability can make it difficult to integrate into electrical grids. But even with these challenges, modern wind turbines have made wind energy the most efficient and inexpensive source of electricity. Wind turbines already provide essential energy for communities around the world, and for many farmers, hosting a wind turbine can be a reliable source of additional income. With continued improvements in wind forecasting, electrical grid infrastructure, and energy storage, wind power might blow away all our energy problems. Next up, learn how solar energy works. Or if you're more of a big picture person,
Okay, so you get the idea. Now, I wanted to give you a sense of scale. I mean, they talked about how big these things are, but when you look at this little person here, you're looking at the size of the blades, and you can see in that little picture up against the house. I mean, these are huge. These are enormous systems that you look at. When you look at you can see the people that are up on top doing work on it. I had the opportunity to go ahead and do some reproductive ecology surveys for tortoises underneath a wind farm. And when you get from that height, if a bolt falls out and gets to the bottom, it's a major projectile. It's a long distance. And so this is an enormous thing that we start looking at. And this is why I think a big part of the future is going to be looking at a lot of what she mentioned in terms of these offshore wind farms. The first one in the U.S. is Block Island Wind Farm, which is located off the coast of Rhode Island. This 5-turbine, 30-megawatt wind farm began operation in 2016, and I think you're going to see more and more of them. Oregon has invested in wind, and I think it's just a matter of time before we start having these offshore wind farms here in Oregon. So this is the state of the modern wind turbine. Commercial wind energy is one of the most economical sources of new electricity available today. We can have a wind farm up in 1 year, and the wind turbines can be set up quickly and cheaply compared to building new coal-fired generating stations or hydroelectric facilities. So this really is a great potential, even though it is intermittent. Okay. It's efficient, it's highly reliable, and it's just the price just keeps falling. It's getting cheaper and cheaper by the day. The environmental impact of large wind turbines is negligible compared with an open pit coal mine or a reservoir, and during their operation produces zero air pollution. Because of these factors, we're definitely seeing it grow at tremendous rates. So what are the benefits of wind power? Well, wind energy is cost competitive. 2016, the average levelized price of signed wind power purchase agreement was about 2.2 cents per kilowatt hour. Okay, it's a little more than that just because of inflation, but it's cheap. This price is cost competitive with gas-fired power plants. So fossil fuels are no longer the cheapest option. Wind power actually is, and the only reason we keep putting in more fossil fuel power plants is because of the oil and gas lobby. Okay. In 2017, the wind sector invested more than $11 billion in the US economy because wind energy creates jobs. If we're going to put up wind projects, people need to be skilled to be able to do that. It employed more than 105,000 workers. So this is a big economic potential boon. And wind energy is diversifying our national energy portfolio, and it's domestic. So we don't have to rely on foreign imports. Okay? That homegrown energy source could help stabilize cost of electricity in the United States and reduce our vulnerability to spikes and supply disruptions due to the increase in cost of fossil fuels. Okay? Wind energy provides income for farmers and ranchers as well as economic benefits to their communities. Revenue varies by region, but wind projects provide the communities which they are located lease payments to landowners of about $3,000 to $6,000 per megawatt. And then you also have your local and state tax revenues, not even including the employment benefits of the jobs that come with it. Wind energy is an inexhaustible renewable energy source. It's plentiful and readily available, and capturing it does not deplete any of our natural resources. At the end of 2017, about 89 gigawatts of wind energy were installed across the US, and analysis indicates that by about today, 2020, installed capacity of wind energy in the US is about 113 gigawatts, or 10% of our annual end-use electricity demand. That's pretty good. Wind turbines don't use water. Okay, water is becoming a more and more precious resource, as we've learned, and Researchers estimate that wind power generation reduced power sector water consumption by about 95 billion gallons, equal to approximately 719 billion bottles of water saved by doing wind as opposed to other forms of energy production. So that's pretty awesome. Wind really is a great option, and it's very clean. Electricity generated by wind turbines does not pollute the water we drink or the air that we breathe. So wind energy means less smog, less acid rain, and much fewer greenhouse gases. If we can increase wind's power contribution to the eastern US grid by 30%, we could reduce carbon production by almost 19%, which is incredible. And it doesn't stop there. Wind energy systems have very low operating costs because, unlike other resources, there are no fuel costs. Okay, so in that case, it's like hydroelectric. Wind energy can be used in a variety of applications. We can do small scale wind for a community or even a house, or we can do large scale when we go ahead and start looking at tapping into the grid. Wind energy is deployed in all US regions and is widely supported by the populations there. Growth in wind power capacity over the last 20 years has averaged about 7.2 gigawatts per year, and 70% of Americans believe the US should place more emphasis on wind energy development. Research has shown that at high levels of wind and solar can reduce carbon emissions by 1/3, with only a 2 to 5% cost increase over what we're currently paying. So there's a lot of benefit here. All right. But there are potential impacts and issues. What does that do to property values? If you have a turbine close by, how much noise is produced? Some people don't like the look of having them there, and what does that do in terms of land around it? Okay, most of the studies I've seen show that there's very little impact on the land use around the turbine. There is some wildlife impact. You do have dead birds, but by and large, it hasn't been as bad as people originally expected. And the biggest downside to wind has probably been the noise factor. Well, how loud is a turbine when it's in full operation? It's pretty loud. Okay. You're talking about right up next to the turbine being or something like your lawnmower or a really loud blender, maybe a vacuum cleaner. As you get further and further away, the sound goes down, obviously, but you still get some sound, like the sound of your refrigerator compressor going on. And so most of the time, you don't see residential areas within 300 meters of a wind turbine. Um, but just to kind of give you an idea of how much impact noise has. What are the wildlife impacts? Well, you hear a lot about human-caused bird threats, but turns out compared to vehicle collisions, buildings, tall building glass, and cats, it's pretty low on the hazard to most birds. So what are the advantages and disadvantages? Well, the biggest advantages are that it's abundant, widely distributed, inexhaustible, has a very high net energy and a low cost, and it's totally non-polluting. What are the disadvantages? Largest potential areas are usually rural because of the impact of all the taller buildings. And you do need a backup power source for when you have calm days because the wind doesn't blow 24/7. And for some people, it may be considered too noisy or too much of an eyesore. Now, that's the main set of notes. I just wanted to do a quick little look at some of these new developments in terms of what they call high altitude wind power. I won't spend a lot of time here, but essentially it's designed to be about 6 miles closer to the jet stream. And you have these little 2 to 4 rotor type things like this for what we call the flying generators. And they're mounted to a very lightweight airframe and would need to be tethered to the ground, kind of like a kite would be, which is interesting because the other group of these high altitude ones are known as kite generators. And there are two main designs that we typically see. Power is generated as the kite is pulled and released, just like you would with a kite. And this also has to be tethered to the ground-based generator. Additional power can be obtained by capturing the rotational forces of the kite as well, if you put a little turbine system up there on top of the kite. And then the other one is a tethered to the land kite as well. Rotational energy is captured by a carousel of what looks to be kites, and they are designed to operate at about a half a mile up in the atmosphere. So there's a lot of potential here when we take a look at this, and I hope you will kind of think about the potential of wind as we move forward. All right, guys, that's what I've got for you. Stay healthy, stay safe, and I'll talk to you soon. Take care. Bye.